Hello. Today we're going to be talking about the two-pointer technique. So, what is a two-pointer technique? The two-pointer technique is where you have two variables, one called left and one called right, and usually this is used on a sorted array. So one's in the front and one's in the back. And during each step of code, you can do whatever you want, and then you decide whether you want to move the left pointer inside or the right pointer inside. And you can keep doing this until they meet, and then that's where you stop. But you can stop before that to find your desired whatever you want to find. So let's go over some examples, okay? So we have given a sorted integer array. This part's important. Usually this technique is used on sorted data structures, okay? So given a sorted integer array, find a pair that sum to a given target. All right. So our goal is to find two numbers in this array that add up to 13. And we return true if it exists and false if it does not exist. All right. So this solution here, it uses two for loops, which is O(n) squared time complexity, which is for this it's not bad, but for larger arrays it can get really slow. So this is not optimal, but we can just run through it anyways. So in each iteration, so let's start. So for I in range length of nums, it's going to be 1, okay? And then it's going to loop through the entire array, testing if each 1 is equal to 13. So first it's going to test 1 plus 3, which is no, 1 plus 4, which is no, 1 plus 6, which is no, 1 plus 8, and as you can see, the target isn't even found then. So it's going to do that until the end of the array is reached, which it takes a long time. So our goal is to reduce this to O(n) time, which is linear time. All right, how can we do this? So we're going to introduce our two pointers here, left and right. Okay. All right. Okay, we have our nums array, and we're going to take our left pointer first, and we're going to set that to the first element in the array. And then the right pointer points to the left side. I mean, the right side, sorry. It points to the last element, okay? Now, this is typically formatted in a while loop. So it's going to say while left is less than right, okay? So what it's going to do, we're going to do is 1 plus 13 equal to 13? No. Is it greater than 13? Yes. So we move our right pointer inside. So now our right pointer is pointing to 10. So now is 1 plus 10 equal to 13? No. Is it less than 13? Yes. So we can move our left pointer in 1. Now, is 3 plus 10 equal to 13? Yes. So we return true. This isn't really a complicated data structure, but it could get complicated. It's not a data structure, it's just a technique you can use. But it can get really complicated for harder problems. All right, so we're going to go over a bit of a more complicated example, but it's still not that hard to understand, okay? I promise you guys. All right, let's try. So first, let's just read the problem first, okay? You're given an integer array height of length n. There are n vertical lines such that two endpoints of the ith line are I0 and I and height to the I. Okay? Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. All right. So what we're going to do here is we're going to use two pointers, of course. And for this example, as you see, the array is actually not sorted. So you can use this on non-sorted arrays, but I'd say for a problem that has sorted arrays, you should use two pointers to optimize the solution. All right, so for this problem, let's see. Okay, So our left pointer goes here, of course, and our right pointer goes here. So the first element in the array, which is 1, and the last, which is 7. Okay? All right, so we are going to compare, we're going to find the area between these two. So as you can see, for these two, the height would just be 1, because you can't have water that fills up to here because it would just leak out. So the tallest height would just be 1. Okay? So the area of that would just be 1, which is the height, times the width, which is just the length of the array. Okay, so if the left is less than the right, then we're going to move the left pointer inwards. Otherwise, we move the right pointer inwards. So for this example, so let's say our left pointer was here and our right pointer was here. So we would move our right pointer inwards because the left pointer is larger than the right pointer. The value at the left pointer, the value at the left pointer, the value at the left pointer is greater than the value at the right pointer. Okay? All right. And okay, let's go ahead and start coding this. It'll make a bit more sense. All right. So let's define our left and right pointers. So we have left is equal to 0, which is the first element, the first indice, and right is equal to the length of height minus 1, which is the last element, the index of the last element in the array. Okay, and then we need a variable to store the current max area that we found so far. So current max, we can just initialize this to 0 for now. Okay, and now we have while left is less than right. Now the point of this is, so you know how the pointers move inwards? This prevents them from going past each other in the wrong way. So it should never do that. It should stop when they meet. So they'll meet in the middle and it stops. It never goes past each other like that. Okay? So, okay, now we're going to find the width of the container. So the width can be found by subtracting left from right. So we have right minus left. And it's always right minus left because right is always larger than left. So if we did left minus the right, that would give us a negative number, and we wouldn't want that. So right minus left ensures that it's always positive and it's the correct calculation. Okay. So what else do you need for area, for calculating area? You need the height as well, right? So the height is always the bar's least. So let's say you're comparing the first one and 7, right? The height is always the lower numbers, the least numbers. Okay. So we're gonna say, let's rename this. Okay. We're gonna call this cur height is equal to min of height left and height right. If you don't know what this function does, it basically picks the least element out of these two. So for our example of 1 and 7, it would pick 1 as the height. Okay. Now we can finally calculate the area. So the cur area is, of course, cur width times cur height. Okay. Now, we are going to update our current max. We're going to update this with what we have seen so far. So we're going to do cur max equals max. And this function is basically the opposite of this. So it will pick the maximal element of the two parameters that you give it. So we're going to compare the current max and we're going to compare current area. So if the current max is already greater than our current area, then it stays the same. But if current area is larger than what we have right now, then it's going to be updated with current area. Okay? Now, we're going to check if the value at the left pointer is less than the value of the right pointer. Because we're going to, if that's the case, if the value at the left pointer is less than the value at the right pointer, we're going to move the left pointer inwards. Okay, so let's check that. If height left is less than height right, we're going to increment the left pointer. Else, if height, if the value at the left pointer is greater than the value at the right pointer, then we're going to increment the right point, decrement the right pointer. Okay, so else right minus equals 1. And that's pretty much it for our while loop. And at the very end, once we're done with this, we are going to return the current max. So our final answer. Okay, I'll run through this really fast. So we have, so, okay. All right, so our left pointer is going to be here, and our right pointer is going to be here. Okay, so, all right, our current max is 0, which is normal. That's what we start off on. Okay, while left is less than right. Left is 0, right is the last indice of the array, so that is true. So we're going to continue into the while loop. All right, we're going to calculate the current width. What is the current width? So the current width, let's count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's going to be 9 minus 1, which is 8. So the right pointer is 8, and the left pointer is 0. The current width is 8. All right, now let's write that down. So current width is 8, and the current height. So we're going to see which one's the minimal value, left or right. So as you see, 1 is less than 7. So the height is going to be 1. Now the current area is just 8 times 1, which is 8. And we're actually going to update the current max because 8 is greater than 0. And that's what the max function does. So it's going to compare 0 and 8. It's going to pick the maximum element. Okay. Now, if the value at the left pointer is less than the value at the right pointer, which it is, then we are going to increment the left pointer. Okay? So now our left pointer is pointing to 8. Now we can restart the while loop. Is left less than right? Yes, it is. So we're going to calculate the width and the height and the area again. So the current width, right minus left, which is now 8 minus 1. So that is 7. The height is going to say, okay, it's going to compare 8 and 7. It's going to pick the minimum element. So the height would also be 7. Okay. The current area is now 7 times 7, which is 49. And the current max is now going to be updated to 49 because the previous area was 8. Okay, so now the current max is 49. Now, is 8 less than 7? No. So it's actually going to decrement the right pointer. So now the right pointer points at 3. Now, at this point, we have found our maximal area, but we still have to run through the entire array to find if there's any more areas that are larger than what we have. So this would keep going. This would go to 6, then, sorry, let me see. So this would keep going. And since 3 is less than 8, it's going to move it here. And then since 8 is not less than 8, they're equal. So it's going to keep going. It's going to keep going, you know. We keep calculating those areas. But the max area we've already found is 49. Okay, it's going to keep doing this. That. It's at 2. Finally, we stop when it's at 6. Since if the pointers end up here in the same spot, then the while loop stops executing. And then at the very end, we return what we have at current max. So it will basically calculate what the max area we have seen so far, and it will store it. And that will remain the same if we haven't found another area that's larger than it. And that's basically the entire problem. That's basically the entire problem. And let's try running it. Let's see what happens. We accepted on both test cases. Now let's try submitting it. All right, we can see that it passed. All right. All right, so that is the basics of the two-pointer technique. It can be used on a multitude of problems, but it's a very, very helpful technique, and I'd say it's worth mastering it. It's seen in a bunch of problems. Okay, the next video I'm going to be covering the sliding window technique. All right.